Hi everyone, it's Paulo Radatz with Apri, and in this video we are going to see the results of our simulation that we have performed in the last video. Let's go to the computer. As you can see here, I closed the mitigation analysis interface, and now I will open the mitigation results interface by pressing the visualize mitigation button. So let me bring it here. This is the interface. As we can see here, we have two types of we have two options to see the results. We have the single bus option, and we have the multiple buses option. Since we have just simulated one bus and one feeder, we are going to be using the single bus option. But in the last video of the tutorial, we are going to talk about the multiple buses as well. Here, with the single bus option, we can select the feeder. And as you can see here, the only feeder we have is 105 bus. We don't have the 4 bus and 123 bus. Why? Because we have just analyzed these 105 bus. So if you analyze the other feeders, you are going to see the other ones here too. But now we just have one feeder. And in that feeder, we have just analyzed one bus, right? So if you try to select the bus, probably we are going to see only one bus, the bus we have analyzed. The next thing we should do here is to select the target for our interconnection. Let's say that our interconnection request is requiring 1.5 megawatts. Okay. Next thing we do, we then select the existing DER option. In our case, since we have not included them, it's going to appear just no DER for us, no existing DER. And then after that, we can see that only the mitigation options that we have applied in the analysis will be now available for us to check or not. Let's start to see the results only considering the grid side mitigation options that we have, in this case reconductoring, and I will just considering as the violations on the overvoltage and overload for generation. So here we have one mitigation option and two violations. We can then press the plot results. Let me bring the results here for you. So one figure that we can get from this tool is this that illustrates the hosting capacity for each setting of the mitigation option. We are now considering reconductoring mitigation options. So we have setting 1, 2, and 3. So we have hosting capacity for each setting and each violation over voltage and overload for generation. For instance, if we see here reconductoring 2, we have for over voltage 1.5, 1.6 megawatts, I guess, and for overload for generation it is above 6 megawatts. Okay, same thing works for Reconductor Tree, so it's close to 2 and 10 for overload for generation. Now, if we want to define the limiting hosting capacity for each setting, let's say for Reconductor 2, the limiting hosting capacity is defined as the minimum value when we consider all the violations. In this case, we have 2 violations. For one violation, it is 1.5, I guess, and for the other violations, it's 6.2 or something. So the limiting hosting capacity for Reconductor 2 will be 1.5, which is the number we have for overload, over voltage. So over voltage is the limiting violation for this setting. Another important thing to show here in this plot is that we have none. None means that we have not applied any mitigation option. So it's just our feeder, nothing changed, okay? So we can close that. And the other plot we have, let me bring it here to you and explain. Here we have our limiting hosting capacity. For Reconductor 2, let me correct that, is actually 1.2. For Reconductor 3 is 1.6. And in this plot, you can see the target that we set, 1.5 megawatt. So looking at this, we can say that there is only one mitigation option that allows the interconnection. And this mitigation option is the Reconductor Tree. So in this case, we can say that this is the best mitigation option. And the cost to apply this mitigation option is in the plot here, which we have analyzed cost. Okay, in this case 20. Yeah, that's all we have for this plot here. Let's now, not considering just the grid, let's not consider the grid side, but only the power factor, volt-var and volt-watt, which are the customer side options. Let's plot. And then let me show you just this plot. In this case, you can see that our target is 1.5, and all our mitigation options are, all of them didn't get above the target. So we could say that in this case, we can't integrate this DI that is requiring the interconnection, because we don't have any option that allows that. But even though we have this scenario, we still define the best mitigation option. In this case is volt-watt tree. And why we do that? In this case, what the software is doing, the software is saying that the best mitigation option, when we don't have any that gets above the target, will be the mitigation option that has the hosting capacity closest to the target. In this case, as you can see here, this guy here is our volt-watt tree, and we don't care about the cost. The only question we do to define the best one under this scenario is that which one has the hosting capacity closest to the target. That's the best one, okay? And finally, let's say that we want to only see the results for the combined. I will plot them here. Well, in this case, you see the target here, and we have 1, 2, 3, 4 mitigation option that gets us above the target. So when that happens, we are going to define the best mitigation option, that one that has the lowest cost. In this case, you can see this is the volt-var 2 Reconductor 2, this one here. And you see that this one has the lowest hosting capacity when you see the 4 ones, right? And that's really interesting, because what we want here is just to get above the target at the lowest cost. We don't want to have 10 megawatts and have a high cost here. We prefer to have like close to 2 megawatts but the lowest cost. And therefore, this is the mitigation option that we define as the best one. All right? I hope it makes sense. Well, let's close it. And finally, to end this video, I'm gonna show you that you can plot the feature schematic. And then in here you can see in the title the feature name, if you are considering or not the existing DR, the target 1.5, the mitigation options we set was just the combined ones, and the violations over voltage and overload for generation. So you can click in this section that represent that bus, and you have results associated to it. The name of the bus, the initial hosting capacity, which is basically the hosting capacity when we don't apply any mitigation option, no mitigation. And then when we apply the best mitigation option, which is VAR2, Reconductor 2, we get to 1.9 megawatt. And the cost associated to do that is also here represented. Well, when you click on this section, you can also click into this plot results button, and it's going to bring us all the figures that we already have discussed. So guys, that's all we have for this video, how we can get results for this type of interconnection studies. In the next video, I will be covering how we can use this tool for more a planning type study. I hope you enjoy it. Thank you for being with me, and see you in the next video.